What's going on, everybody? It's Mr. Gus, and I'm back in the physics classroom. We're still doing momentum here. We're kind of wrapping up our discussion on change in momentum or impulse and the equivalences between the both. So let's go ahead and remember where we have been. And what we've discussed so far is that we have two ideas, similar to energy and work, but we have this vocab word, impulse. An impulse is equivalent to a change in momentum. Momentum we've called inertia in motion, so it has to do with mass and velocity, but we said it's a change in that. So this is our expression for momentum, is change in mv. I've got to get a better marker. Oftentimes written as mass times final velocity minus initial velocity. And the reason we write it this way is because it is rare. It's not impossible. We'll see it happen in certain scenarios, but it's not common for mass to all of a sudden change as the result of an outside force. So because of this, we say that mass equals a change in velocity. Now this is my change in momentum. The impulse expression is always F net times time. This, when I refer to impulse, is the outside force that acts on a system or a body or an object to change its momentum. All right? And we've talked through a couple different demonstrations around this in class with throwing objects and catching objects and locking our knees and bending our knees and whatnot. But specifically today, we went ahead and did our egg drop lab. Here was the challenge. I gave you all an egg. And it's not hard boiled, it's just a normal egg. You can kind of wiggle it around and hear it. But I gave you the egg, and I gave you 7 sheets of paper and 1 meter of tape. And I said, hey, protect this thing. Let's figure out a way to protect it. So in order for us to kind of think around what are some ideas I should be thinking about, let's go ahead and imagine this egg being dropped from the ceiling with no added protection. Okay, so let's go ahead and draw this. Let's say egg, just raw egg being dropped. And let's frame this problem. So if I have my raw egg and I drop it from the ceiling, the only force acting on it is the force of gravity. Its initial velocity up here is 0 meters per second, which means it's in free fall. As it approaches the ground, it has a new final velocity. It's still Fg is acting on it, and there's a final velocity acting downward. Now, this fall alone, the fall from the ceiling right to the area directly above the floor is not going to break the egg, but it will accelerate the egg. It will speed the egg up. But this motion here, this free fall kinematic expression, this motion here is not what's going to break the egg. It's the very, very small time frame when that egg is in touch with the ground. So let's zoom this thing in. So if I look right here, if I zoom in on this collision here, I'm talking about the moment between when the egg is directly above the ground, we can call this the final velocity from up here, all the way down to this velocity when it comes to rest. It is this difference, it is this change in velocity that is this change in momentum. It's bringing it to a stop. It's this not instantaneous, but nearly instantaneous motion of moving and stopping. Now, with that collision, what we see is obviously there's a force of gravity pulling it down, but in order to stop that egg, there needs to be a larger force normal from the floor. And that force will change. It will start small, it will grow, and eventually it will equal the force of gravity. That way we're at a net force of 0 because it's at rest in the ground. But this upward force, this normal force, is the force that will break the egg. And it's the Fg-Fn combination that makes it my F net in my impulse equation. So this is what I'm trying to minimize, right? That normal force cracks the egg, or at least the introduction of that normal force cracks the egg. So when I'm thinking about designing a device with paper that will prevent this from happening, I think about a couple of things. And what I asked you all to do is let's brainstorm some things that might work. What are some things I might do to protect the egg, and how might that impact it? Or why, right? Like, maybe not how, let's make that a why. So what are you going to do and why? Okay, and there's a couple different things here. The first thing that most students say, and they don't do it well, they don't construct these things well, but the first and foremost, they say, build a parachute. If I'm going to protect the egg, the first thing I'm going to do is build a parachute. And so I ask, why? And they say it slows it down. And I agree. It does slow the egg down. My question is, where does it slow the egg down? Is this change in the device, or this addition to the device, is that going to slow the egg down in its free fall? Is that going to affect it here? Or is that going to affect the egg in its collision? Or how will it affect the collision? This is what I'm really asking you, right? So if we think hard on this, what will a parachute do? Well, the parachute, I think, will end up changing the forces that are on the egg as it falls. It will no longer be in free fall. We're introducing intentionally air resistance into my system, onto my egg, so that it doesn't free fall. We're intentionally adding some force. Now, it's not a force that's larger than gravity, force of air, right? It's definitely not larger than gravity because the object is still accelerating downward, but there is an upward force on it that allows it to accelerate more slowly. So, does it slow it down? You betcha. What does that change? Well, that changes the velocity above the ground is smaller. That's all it does. It makes sure that the egg is moving slower when it contacts the ground. If the egg is moving slower at a smaller speed when it contacts the ground, that will change by change in velocity. That will change the amount of momentum the egg has as it reaches the ground. And with less momentum in the egg, a smaller force is required. And that's what we're saying here. So why? Well, the velocity above the ground is smaller, so the F net required is less. And if there's less force required, the egg stands a greater chance of surviving. But now, let's envision a high school student building a parachute out of paper alone, right? That's the only thing we do is build a parachute out of paper. If we do this, what are the chances that this egg, as it falls with the parachute attached to it, hits the ground in my classroom, hits this ground, and doesn't crack? Eggs, in terms of cracking, are pretty fragile. That's why you can take them in your hands and just kind of tap them, and eventually they'll start to crack. So the parachute alone doesn't necessarily save the egg. There's clearly something happening with this very firm, rigid edge of the egg and the very firm, rigid surface of the floral. So there's something else I may need to do. We've talked about changing the velocity. Okay, so I've minimized the change in velocity. I've minimized the egg's initial momentum during the collision. What else can I do? How else can I work to minimize the force? And so what we say is that if, and I'll say it slowly and clearly, if we have a fixed momentum value, if we have a fixed change in velocity, we have fixed that. We've already said this is the minimum amount of momentum I can store in the egg, or the egg will have after a parachute. I need to now find a way to change the time that this collision over here happens for. If I can somehow lengthen this time, that will dissipate the amount of force, or spread the force out over a longer period of time so that the egg stands a better chance of surviving and feels a smaller force. This is the same idea with an airbag in your car. It's the same idea with crumple zones in a car. It's the same reason new football helmets have the caves that cave in during collisions. It's the same reason we use pads when we play contact sports. It's the same reason we have rubber soles on our shoes. We're trying to increase impact time to decrease the amount of force felt. So what's one thing we could do? Well, some students say, let's use padding. And they have different ways of building padding. Some are successful and some are not. So why would I build padding? This is to increase the time of collision. So whereas the parachute was really talking about this motion, the parachute was changing the momentum build up from the force of gravity. This change, this padding change, is really dealing with just the collision, just these milliseconds where the collision is happening. Now, could padding add some air resistance? Sure, based on how it's built, but really at its core, padding is changing the collision itself. So padding will increase the time of the collision. How will it do so? It will contact the ground first. Because it contacts the ground first, it then, we can say, absorbs the force from the ground, which we're calling Fn, first. In effect, that force then is applied over a longer time. Therefore, we see a total decrease in the F net required to stop the egg. Because the paper padding hits the ground first, the force immediately acts on the paper or the padding. The padding absorbs that force before the egg does, therefore increasing the amount of time that force acts on the device. Not necessarily the egg, but the device as a system. Because of that, because of the increased time that the force is applied to the device, there is a smaller net force required to bring that object to a stop. These are two different things that students do and the reasons behind them. Again, there's two different parts of this motion. There's the acceleration, downward motion, the increase in momentum from rest to moving, and then the sudden stopping of the object and the rapid decrease in momentum down here. Both of these are areas in which you can change some factors and change some aspects of a device or the egg's motion so that you can minimize this rapid change, this force, this rapid change in momentum or this rapid impulse down here to protect the structure of the egg. Okay? Now the challenge here is, and you can see this, the challenge here is to think about this type of process, this type of engineering problem in all kinds of things. You open an Amazon box, there's either packing peanuts or there's inflatable bags in there. All these types of protective ideas exist all around you. Just open your eyes and take a look at some examples. Okay? If you have questions on the egg drop or this change in momentum and impulse scenario, drop me a comment in the comments, send me an email, ask me in class. But until next time, see ya!